You know, all the headlines are about these giant AI models that can write novels and create incredible art. But what if I told you that while we're all looking up at those skyscrapers of AI, a quiet and maybe even more profound revolution is happening right at our feet? The real question is, could Tiny actually be the next big thing in AI? Let's dive in. It's so easy to get mesmerized by the big, flashy stuff. But as Edge AI visionary Funny Bhushan Adler says, there's a silent revolution happening that most of us are completely missing. This is a totally different way of thinking about intelligence, one that doesn't live in a giant data center, but is woven into the world all around us. Okay, to really get your head around this, let's use a little metaphor. We all know the AI skyscrapers, right? The massive, powerful large language models like ChatGPT. They're amazing, but they need a huge, power-hungry foundation in the cloud. But what about the other side of the coin? What if there were AI fireflies? What is this mysterious technology that's super small, can be literally everywhere, and can run for years on a tiny coin battery? Well, these fireflies have a name. It's TinyML, and it is the engine powering this whole silent revolution. It's all about putting a little bit of smarts into the smallest of places. So, what on earth is TinyML? Well, it's tiny machine learning. And it's basically the art of cramming an AI model onto these incredibly small, low-power computer chips called microcontrollers. And when I say small, I mean it. We're not talking gigabytes of memory, we're talking kilobytes. A single high-res photo on your phone takes up more space than one of these entire models. It's kind of wild when you think about it. And the difference in scale here is just staggering. On one side, you have LLMs with billions of parameters, guzzling megawatts of electricity in a data center. On the other, tiny ML models have maybe a few thousand parameters and sip microwatts of power. That's a millionth of a watt. They don't need the cloud at all. They live right on the device, laser focused on one specific sensing job. So what does that actually get you? Well, it boils down to three huge advantages. First, the power use is so incredibly low that these devices can run for months, sometimes even years, on a single tiny battery. Second, you get answers in real time. There's no sending data to the cloud and waiting for a response. It's instant. And third, and this is a really big one today, privacy. The data is processed right there on the chip. It never has to leave. Now, I know what you might be thinking. Okay, this is kind of cool, but it sounds like a niche little project for hobbyists. Let me tell you, that could not be further from the truth. This is a full-blown movement, and the biggest names in tech are pouring money into it because they see just how huge the potential is. I mean, just look at who's involved. The whole tech world is mobilizing. You've got the software giants like Google and Meta building the programming frameworks. You've got the hardware leaders, ARM, Apple, Qualcomm designing the special chips. And then there's a whole new wave of brilliant startups building the tools to make it all work. This is not a fad, folks. This is a foundational shift in computing. Okay, so we know what it is and who's building it. But let's get to the really fun part. Where is this technology actually showing up? How is it going to impact our lives? This is where it gets really exciting. Okay, think about healthcare. Imagine a wearable like a smartwatch that's constantly monitoring your vitals. Because of TinyML, it can detect an irregular heartbeat or even help predict a seizure right there on your wrist without ever sending your private medical data to a server, all while the battery just goes and goes for months on end. Or how about your car? You could have tiny, cheap sensors that just listen for subtle changes in vibration to predict an engine problem or a tire failure way before it becomes dangerous. And because they cost pennies, you can put them absolutely everywhere, making every car on the road that much safer. Let's go somewhere totally different, a farm. Picture a smart sensor stuck in the soil in a huge field, miles from the nearest cell tower. That sensor can analyze the soil and spot the early signs of crop disease all by itself. For places where internet is spotty or non-existent, this is a total game changer. And in a factory? Oh, it's a revolution. You can add a little bit of intelligence to every single motor, every conveyor belt, every machine. You can predict when a part is about to break, preventing those super expensive shutdowns. This is the industrial Internet of Things, but on a scale we've just never seen before. So here's the key idea I really want you to take away. This isn't a battle between the skyscrapers and the fireflies. It's not one or the other. They are two essential pieces of a much bigger puzzle. They're designed to work together to complete the entire AI spectrum. It really creates this new three-tiered system of intelligence. At the very top, you have the big cloud AI, the LLMs doing the heavy lifting and the complex thinking. In the middle, you have edge AI on more powerful devices. And then, at the very foundation, you have TinyML. It's the last mile of AI. Think of it like the billions of nerve endings for this bigger system, constantly sensing and feeling the real world. It really comes down to two totally different philosophies. On one side, you have AI maximalism. That's about performing these incredible, extraordinary feats with extraordinary resources. You could call it the AI for the massive. But TinyML is all about AI minimalism. It's about bringing simple, basic, but useful intelligence to billions of ordinary devices. It's the AI for the many. And you need both. So, what does all this mean for the future? And more to the point, what does it mean for you? Well, ironically, the opportunity here is anything but tiny. I mean, just follow the money. The market projections are wild. Analysts are predicting the TinyML market is going to explode from hundreds of millions today to tens of billions of dollars by 2030. That kind of insane growth tells you one thing. There's going to be a massive, sustained demand for this tech, and for the people who know how to build it. Which leads to a very practical question, especially for any of you out there who are engineers or developers. Should you be learning this stuff? The short answer is a resounding yes. Here's why. First off, expertise in this area is still pretty rare, which makes you incredibly valuable. Second, being forced to work with these crazy constraints, it just makes you a smarter, more creative engineer. Third, you're helping to democratize AI, bringing it to industries that could never afford a giant cloud solution. And finally, it's just a cool space to be in, blending hardware, software, and AI all together. So as you go about your day and think about the future of AI, just remember this one last thing. The big revolution isn't just happening up in those giant data centers. It's also happening silently all around us, in billions of tiny little sensors, all becoming intelligent while using less power than the watch on your wrist. That is the incredible hidden power of TinyML.